This conference will now be recorded.
Oh, hi, Amir.
Hi, how are you doing?
Good. How are you?
Yeah, I'm good. I'm good. How is it going?
It's going great actually. Yeah, it's getting cold here. How's Louisiana?
Oh yeah, Louisiana started to get cold early this week. So we
Oh,
started to see,
really?
yeah,
You
55
know,
in the mornings and 50.
I used to live in Louisiana.
Oh, really? Oh, wow. That
Yes.
no, the first time
I
for me to know that.
Not many people know about it, but yeah, Louisiana, yeah, I used to live in Plaucheville. I'm not sure you know that area, like
Mm,
Cottonville, Plaucheville.
okay.
Or like the nearest airport was Alexandria Airport.
Oh, Alexandria Airport. Yeah, I know the area. Like this is in the north, a bit in the north of Baton Rouge. Of course, I'm in
Yeah.
Baton Rouge.
Ah,
That's the
I
capital.
see.
That's the
I
capital.
see.
Yeah.
Right. I've been in Baton Rouge couple times with my host family. Back yeah, at the time I used to live with my host family in Louisiana. So
Hmm.
yeah, I see. Yeah,
Yeah,
and I miss the winter in Louisiana. It's usually, not super cold.
oh, yes. In general,
Yeah.
Louisiana has a warm weather, of course. It's in the south, and
Right.
the summer here is terrible. Like you can see how hot it becomes up to 90, 95, sometimes 100. So
Right.
it's really hot here.
Yeah. At that time, it was like about 11 years ago, and I remember at the time, I could survive just with hoodie, like yeah, hoodies.
Hmm.
Not like in New York or other regions. I
Hmm.
have to wear like I have to prepare a lot of clothes because yeah, the
Yeah,
weather is very dynamic. I
yeah,
mean,
definitely.
yeah, Louisiana, like summer in Louisiana is also hot, but at least you don't need those like Canada Goose type of very heavy clothing.
Hmm.
Yeah, but
Yeah, of
I
course.
miss,
So
yeah, I
where are
miss
you
that
now?
time.
You
I'm
are
in
in
New York now,
New York.
but
Oh, wow, New York is
I
cold place.
yes, I moved around states a lot. Actually Louisiana was my first state in
Hmm.
the US. Yeah,
Okay.
first place I lived in
Oh, okay.
when I
That's good
first
to
came
know.
to the US. And
Hmm.
yeah, I've been moving around, but now like yeah, I am in New York.
Hmm. Okay.
Yes. And um I definitely miss the food there so much.
Yeah, Louisiana has brilliant food.
I
They like have
Yes,
their own spices. They have
I
their Oriental kitchen.
know.
Yeah, they are famous for them, especially the
I
crawfish. They like it so much.
yes, I gained like 30 pounds during 1 year.
Oh wow, that's
I really and I really miss the food there, like
mm,
gumbo, jambalaya, and um I went to high school back then when I was in
hmm,
Louisiana, and
hmm,
the high school meals were so amazing. Like
hmm.
usually and in other regions, high school foods like the lunches are not that great. It's actually more, yeah, it's really bad.
Oh,
But in
okay.
Louisiana, I remember the memory that, the lunches were really, everything was so fresh. The
Yes,
meal
yes,
changes
that's
every
true.
day. So great.
Yeah, that's true. I mean,
Yes.
yeah, honestly, the thing that I don't like about it is just the roadways here. They are not really well maintained, and
Oh, really?
yeah,
Ah,
that's one of the troubling things. And I'm afraid the bridges as well. And
I see. I see.
the other thing also is that they don't sometimes they don't have sidewalks. I don't know how, but that's
Oh, they don't
if you
have
look,
sidewalks?
yeah, you look at many streets, many main streets, big streets,
Okay.
and it is surprisingly sad that you don't find sidewalks, so people cannot run or walk or do any exercise. Or it is terrible here in terms of this, and
Oh, I see.
it's a
Oh.
strange city. Huh? Like
Wow.
I have never
Oh,
seen
I
this
see.
in the United States. Like any, all usually they do have sidewalks and people run and
Right.
exercise in the afternoons, but
Right.
here it's not the case. So
Mm.
I guess
Oh.
maybe they don't want to exercise or something.
I see, I see. I mean, where I li lived was like very countryside, so
Mhm,
it's yeah, we definitely didn't have a sidewalk. We just had
mhm.
a like a road for cars only. But I know Baton Rouge is more, it's more city, so I
Yes.
understand your concern. Oh, it's shame that I didn't really visited New Orleans when I lived in Louisiana. I think I only visited like once or twice just to go to the airport,
Hmm.
but I
Hmm.
really miss the culture there so much, like Mardi Gras, king cakes, and
Yeah,
St. Patrick parades. Parades are so great there.
yeah, they are famous for that, but I don't like the king cake, to be honest. It doesn't taste
Why?
really good. I'm
How about
sorry.
beignet?
Yeah, yeah, I like it. I mean, it's better than the king cake at least. But this
Right.
green, yeah, the green, yellow, purple creams are terrible,
Right.
and they are very high content of sugar.
But I actually like the concept of it. I guess like more than the taste, I think I like the concept of the king cake and also the culture itself.
Mhm.
But yeah, oh, it seems like people are arriving here.
Yeah, looks like.
Yeah, Amir, I actually send you an email. The like like a list of people who
Yeah,
will
I just
join
read
today.
it.
Okay, great. Yeah, I just want to let you know, like beforehand, who
Hmm.
you will see these people today, but you have basic background of who's from where and so on.
Yeah,
But
thank you for doing this.
of course, I will share a feedback after this Q&A session too. But yeah, Hamid is the main requester. He's from EAC Consulting in Florida.
Hmm.
Yeah, so I'm waiting for him mainly, and also other five people. All those five people confirmed that they will join today's Q&A session.
Hmm.
But yeah, Amir, thank you so much for your time again, um and you can just share your like experience. It will be great if you can share your experiences, and if you have any tips, yeah, then it will be great if you can kind of share with those engineers today.
Yeah, sure. And do I have an option to share my screen if I want to show something on?
Oh yes,
Um,
sure,
okay,
yes, yeah, just please let me know. Yeah, as soon as you
okay,
let me know, I will set you up.
okay.
But yeah, you
So
have that
sometimes it's
option
easier to
to
discuss something
show.
on a model or show something that can be. It's usually easier for the people to digest it right
Right.
away instead of
Yes, I
talking just.
completely
Yeah.
understand.
Okay.
Thank you.
You are
Yeah, thank you
welcome.
for asking that. I think Isabella is here. Hi Isabella, can you hear me? Or yeah, you can. It seems like you're muted right now.
Yes, I do. How are you?
Oh, good. How are
Hi,
you?
I can hear you.
Okay, great. Yeah, in case in
I'm good,
couple of
thank you.
Yeah, a couple of minutes. If you have any question, you can mute yourself, but when if you have any question, feel free to unmute and speak. Ask questions to Amir. All right.
And thank you so much. I will.
Thank you. Thank you. Amir, it's time, but could you give us like one more minute in case
of
engineers
course.
are still kind of, yeah, coming in?
Of course.
Thank you.
You are welcome. Hello, Angela. How are you doing?
Hi, Amir, how are you? Doing really
Yeah,
good. Thank you for
I'm good.
asking.
Yeah. Hope you're doing well.
Yes, yes. How about you, Amir?
Yeah, I'm great. I'm good.
Are you in the office right now, or are you
Yes.
in the office?
Yes, but unfortunately, I'm not sitting on my computer. I'm sitting on another like a shared computer in the office. So because we do have some issues with the headsets and the speakers, sometimes those meetings we like to do them from this computer. But anyway, I mean, I can still have access to Midas and some useful files.
Great, great. Thank you so much, Amir.
You are welcome.
All right. So Hamid is here now. Hi Hamid, can you it seems like you're muted right now. Could you unmute yourself and maybe speak up? You can unmute yourself by clicking the microphone icon in the bottom side of this meeting platform. Or you can connect your audio by calling this number. I will share that. Oh, hi Hamid. It seems like you're now connected. Your audio is now connected. Can you? Okay. Hi Hamid. Amir, do you hear anything or am I?
No, I
Okay.
just hear you.
Okay. I just want to make sure. Hamid, could you maybe, it seems like your computer audio is may not working, so could you actually call the phone number I shared in the chat box, or either you can also find the number in the invitation email as well. You might need to type access code, but yeah, I will appreciate if you can connect your audio so you can directly speak with Amir. Okay. So while Hamid is working on it, working on the audio, I will share. I will introduce Amir, Dr. Amir Botros, to all the attendees. So, Dr. Amir is currently working for SDR in Louisiana office, and he's specialized in load rating, a lot of load rating research projects, and also construction stage analysis. So the background of this meeting, Hamid Hamid Adnan Jafi from EAC Consulting. He's in Florida. He raised the question about construction stage analysis, and Dr. Botros was open to kind of share his tips and knowledge about construction sequence analysis in Midas. So yeah, that's how we are here today. While we are waiting for Hamid, hi. Yes, is this Hamid?
Yeah, I'm Hamid.
Okay, great. Yes, we can hear you. Maybe could you speak up a little bit? I feel like your voice is a little bit small.
So I may need to.
Oh,
Is it better now?
Yes.
Yeah.
Hi,
Sorry about
Hamid.
that.
How are
Yes,
you?
good. How are you?
Good.
Thank you.
Yeah, so I just introduced Amir and you to the attendees group. Hamid, could you maybe first start with your your specific questions about construction stage analysis?
Yeah. First, hello everyone, and thank you, Amir, for actually helping us with this. I appreciate your time and actually your help. So the issue is that I have some correspondences with my support team, and actually at the end I got actually some solutions for my actual questions, but I would like to double check them with you to make sure that I'm on the right track. So the first question was that, as you know, and based on Ashton directive, we have to use actually for composite steel beams, for composite steel girders, we have to use different actually stiffness properties when analyzing the girder under the effect of dead loads and live loads. For dead loads before the composite action, we have to use non-composite properties or the properties, the stiffness of the steel alone. And then for dead loads after the composite action, we have to use long-term actually stiffness properties that takes into account creep. And for post-construction stage loads, for example, such as earthquake or moving load, live load, we have to use short-term actually properties. But the way that we usually define construction stage in Midas, with that procedure, at the end, Midas will use the long-term properties, I mean, considering creep, for all actually loads other than the dead load before the composite action. So it means that even for the for analyzing live loads, Midas uses a long-term stiffness property. If you have a determinate structure, for example, a simply supported bridge, it doesn't matter because the support reactions or the bending moment in the beam is not affected by the stiffness of the structure, because the structure is basically statically determinate. But for indeterminate structures, such as, for example, continuous deck, if you have, for example, two-span continuous girder, the stiffness is important in distributing the actually bending moment in negative and positive region, and also in determining the support reaction. So I had some correspondence with Midas, and at the end, it turned out that if we add a dummy, something that they call dummy, stage at the end, and in that stage, actually I add some boundary condition. I can share my actually my monitor with you, and I show you how they actually guided me. So they asked me to add a dummy stage. In that stage, I just need to activate some boundary condition. So in that boundary condition, I just need to actually modify all scale factors that have been already defined to take into account creep effects or to take into account the long-term actually stiffness of the composite beam. I just need to modify all of them and change them to one, to unity. And in that case, Midas will consider the short-term stiffness of the composite beam for all post-stage construction loads, such as moving loads. So it seems that this actually approach works. But I just wanted to double check with you. And I've done some sensitivity analysis, and I have an idea that this is an effective approach. It works, it's reasonable, but I just wanted to make sure that actually everything is correct, and if you have any idea, any discussion about it.
Okay, so as far as I understood from your question is basically going to the inclusion of the when we model any composite bridge, we have three different phases that we are going through. The first one, when we have the girder section only activated, which is the steel beam section only, and you have all the dead loads applied, like the deck weight, and those weights are just applied on the stiffness of the non-composite section. This is one stage. And then the other stage, after pouring the deck and you have the section composite action activated, then you have a stage when you check the your girder having before the long-term effect is considered. So this is when you use the modular ratio between the steel and the concrete, the N value. And the third stage, when you include the creep effect, which is the long-term effect, and you include 3 times the modular ratio. That's what you are questioning, how we model this in Midas. Is this correct?
Actually, generally speaking, yes, but more specifically, I want to see, as I said, Midas should use different stiffness properties when analyzing actually different loads that is applied to the model in order to determine the bending moment and, for example, shear forces. So Midas should use different, because based on AASHTO, as I said, for analyzing dead load before the composite action, the software should use the property of the steel alone, with no concrete. That Midas actually does that actually. For analyzing the dead load after the composite action, Midas should use the actually long-term stiffness property. But for analyzing the live load or moving load, any post-construction load, Midas should use actually the short-term stiffness property. So after we define all actually stages, all construction stages, at the end, Midas should use the properties that I mentioned.
Yes, that's true. Okay, go ahead.
Yeah. And now, so if you use just, for example, MATLAB, Midas has a tutorial for construction stage. In that tutorial, it clearly actually explains how to, for example, define construction stage number 1, number 2, and how to activate and deactivate. So different boundary conditions, elements, load, etc.
Mm-hmm.
If you follow that actually tutorial, at the end of the day, Midas will use long-term stiffness properties for analyzing live load. That is not really correct.
Mm-hmm.
Based on that, because this is how Midas will actually follow the procedure. It will first, for example, assume that you have a non-composite beam, and it will place the wet concrete load and weight of the girder, we'll consider it and assume that the section is non-composite. That is correct. And in the next step, when you activate the composite section, so and from here your section is composite. Now, Midas will actually use the long-term properties for analyzing the rest of the load, for analyzing any additional dead load and any live load. So why? Because when you actually ask Midas to consider long-term properties, to consider creep, it will use actually the long-term properties for any kind of load. It doesn't distinguish, for example, dead loads from live loads. So this is how it works. So this was the problem. The problem was how to modify this actually issue. The question was how to modify this issue and ask Midas to use short-term properties for live load and long-term properties for other dead loads. So this was the problem question.
Okay, so let me, if I can share my screen, Hope, so I can just show Hamid something. It will be much more easier.
Yes.
Okay.
Do you have any pop-up with message? Yeah.
Yes, yes, I have seen it now. Okay, Hamid, thank you for your question. I think that's a very important question. Usually when you deal with composite bridges, either, by the way, either if it's steel or this issue is always something that is very important to consider. What stiffness are you checking your element for and under which load cases? So there are load cases where you need to check the I will not say short-term stiffness, but basically when you use the modular ratio, the regular modular ratio for the section. What I mean by the modular ratio, of course, the modulus of the steel over the modulus of the concrete. And when also you want Midas to understand that the long-term modular ratio should be used. So to me, when I do this thing, I usually go back to the definition of the section. So you can see my screen, definitely, right?
Yes.
I can see.
So whenever we define that composite section, there is something that, to me, I think this takes care of this issue that you have brought up. When you define the composite section here inside Midas, you have part number 1, which is the girder section. Then you pick all the properties for the girder section here. Yeah, I'm sorry that I just jumped right away to this, but I need to give some quick introduction here to something. Okay, so this just for everybody to be following on this. So this example that I'm showing to you is just a precast concrete bridge. It's not steel one, but the concept, I'm just going to explain your question or just answer your question based on this bridge. But this is just a precast concrete bulb T sections that are composite with the deck here. And this is a cross section of the bridge. So this bridge is composed of 4 girders, like you can see. Those are the interior girders. This is the exterior right girder and the exterior left girder here. So whenever I come to define the composite section here, I just define first the section for the girder itself, which is the steel girder in our case. And those are all the properties of the girder. And then later on, I jump to that window here to define the composite section properties. So here you will have the girder section properties defined, basically, and then you have the slab part, which is the the deck slab here, all the geometrical properties defined. What takes care of your question is this part here. What modular ratio are you using? So this modular ratio for when you say the modulus for the girder section over the modulus of the slab section, of course, this modular ratio is 1.3 because we are talking about concrete here. And this concrete, we have a grade for the pre-stressed concrete. This is 8.5 KSI, and for the slab, it's 4 KSI. So that's why you can see the ratio is 1.36, but this is for the steel is going to be something on the order of 7 or 8 or whatever. It depends on the concrete modulus that you are using for the deck. So that basically, this number here take care of the short-term analysis or the short-term stiffness. So if I go now and analyze this bridge, I defined in this model everything, including the dead load, and the live load and everything, and also the construction stages, if I go ahead and run this model, this means all the cases are going to be checked for this short-term stiffness, taking care of this model. So if you want to include the long-term ones, I believe all what you need to do is just to include the multiple models of elasticity, and then you can put your modular ratio with respect to creep and your modular ratio with respect to shrinkage. So let's say roughly if we are talking about steel and we are using the modular ratio n for the short-term analysis and you are using 3n for the long-term analysis. So all what you need to do is to define how this ratio is going to change for the long-term analysis. And then later on, when you display your result, you will be able to see when did Midas use this property for checking the loads, let's say the short-term loads, including the dead load and the live load. And then for the long-term effect, when it's going to use this modular ratio to checking the results for the cases that apply for the long-term effect. So I think this should answer your question regarding what modular ratio are you using. This is for the short term, this is for the long term. I also see your point about the answer that you got to your question is an indirect method to apply it. If you go and define in the construction stages a dummy stage, let's say here I defined all the stages for the bridge, including the stage when I have the girder section only applied, and then the stage when we have the deck weight applied after pouring the concrete, we have the fresh weight of the concrete applied on the girders, and then this is the stage when I activate the composite stiffness, which means the deck stiffness is now coming into action and activated with the deck. So both the girder and the deck are now one piece, and the composite girder properties are activated at this stage. Then after this, I apply the barrier load, and then the live load, of course, will be applied on the composite section. If you come here and apply another dummy construction stage or something, and this dummy construction stage, you can associate it with the section properties. Here you see when I define the section for construction stage, this is the composite section that I showed for the interior girder. I always have here the option to say or indicate that part number one of the section, which is the girder part, is going to be active at this stage, at this particular stage, when we have the girder only applied in the structure. And then part number two, which is this slab, is going to be active in the composite stage. So you can always play with part number two. That's another way that you can define this long-term effect if you want to do it the indirect way, and not the way that I just described for the modular ratio. If you want to do it this way, you can always have a new section defined here and play with the stiffness of part number two to reflect the long-term effect, the creep and the shrinkage. And you can use this section in this dummy stage or whatever, and then you can check whatever results you want to check on the long-term effect from this part. So those are two different approaches to do it. One I will say more direct approach if you consider here defining the long-term effect while defining the modular ratio. And I think this is going to be better and easier because I believe this is taken into consideration by Midas. Otherwise, they will not include those stages in the first, those cells here in the first place. Or the other way to do it, if you want to go in the classical way, I will say, and just add a construction stage here, a dummy stage, and associate with this stage the definition of the section here. You can have your composite section that reflects the long-term stiffness, and you can always play with part number two to reflect the long-term effect or the long-term stiffness, and you can activate part number two in that dummy stage that you will add. And this way you can also take care of this long-term effect or the creep checks. So I hope this answered your question so far.
Hamid? Hamid, do you have any follow-up questions, or do you? Yeah. I cannot hear you. Okay.
Yeah, I guess
Okay.
his mic is open.
Yeah, I'm not sure what audio issues he's having, but at the meanwhile it seems like Buddy is having a question in the
Hello?
chat box. Yes. Hi
Can you?
Buddy.
This is Hamid speaking, actually.
Oh, this is Hamid. Sorry.
Hello?
Thank you, Amir, for your explanation. Can I talk?
Oh, yes, Hamid. Yeah, you can go.
Yeah. Actually, Amir, thank you so much for your explanation. But my problem is that based on what actually I agree with what you did now, but following this approach, Midas will use the line term or the section properties taking into account creep for actually analyzing live load. So if you, for example, if you find the deflection of your beam at the middle due to live load, this deflection has been determined based on line term properties, with the way that you actually just defined your actually construction stage. In order to investigate it, you can just simply change the actually line term properties of the concrete, and you will see that the deflection will change. So it means that Midas is using the line term properties. For example, if in the actually window that you are showing to us now, if you change the actually creep effect, multiple modulus of elasticity here. For example, if you set it one time equal to 1 and then set it equal to 2, 3, 4, and whatever, and then you compare the deflections of the beam, you will see that every time Midas gives you a different number. Because of the way that we have defined the different stages, Midas uses the line term property at the end. So you can just investigate it. So it means that
I get your question about this, and that's why honestly for the bridges that I worked on, I was always using the short-term modular ratio here whenever looking into live load analysis and all those cases. But the idea of, if you want to control it, I think this idea of having the construction stage that only reflects the long-term effect under dead load, you can have this dummy stage and define to associate it with the long-term effect, and you always know that you are only looking at this stage at the dead load only. So you are just not looking into any information coming from the load case, the live load case that's analyzed based on this stage. You can always control this thing, I believe, like the construction stage can only, yeah, go ahead.
Yeah, sorry, I'm so sorry. So go ahead.
So the idea is, if you because usually when you define those load cases, you associate the section that you are using here. So here, for example, this section, I'm just using the short-term properties or stiffness. So I know that this section is good for live load analysis, and I can extract results for the live load using this section. But if I define a section here that accounts for the property for the long-term effect, and I rerun the analysis again based on this section, I will only use this data for the dead load cases. That's what I'm trying to say. Not for the live load. You can end up also doing two models, Hamid, like having a model that is using the short-term effect, and you know that this model you are going to use the live load analysis from that one, and have the other one that has the long-term effect, and you can have that model for the dead load effect if you are more comfortable to do it this way.
Now, I had as I said, I had a long actually conversation with Midas support team, and this is what we ended up with. If I can share my actually screen, I can explain the outcome of my discussion with Midas team, and then I can have your actually opinion on that. How can I share my screen? Is there any way that I can share my screen?
Yes, I will. Yeah, you should have a pop-up window. You should. Hamid, do you see any pop-up window?
I think so.
Okay. Yeah, we see your screen now.
You can see my screen. So here I have a actually two-span composite beam.
Yeah, we can see your email screen, not the model screen.
Yes.
Yes. So this is my. Can you see my screen? Two-span.
No, you have to change the screen you're sharing. Right now we're seeing your Outlook.
Okay. So can you see my screen now?
Yes.
Yeah. Okay. Thank you. Sorry about that. So this is how. In this case, I have my composite girders are actually steel composite girders. But as you said, the issue is the same. So, but this is my actually composite actually beam. I have a steel beam, the basic beam that is steel and the concrete above it. And my goal is to use a single model in order to actually analyze both dead load and live load. So that's why I have defined multiple modulus of elasticity, and as you said, here I have n, and here I have 3n. And as you said, yeah, in this case my n is larger because my basic beam is steel, but in your case your basic beam was a concrete beam, so you had a smaller.
It's a different section.
Exactly. But now when you activate this multiple modulus of elasticity, this Midas will actually create, if you can as you know, you can just investigate it. Midas will create some actually sections in a actually menu called section stiffness scale factor. If you just open it, you could see that, for example, here I have for positive. You could see that you have actually different. Oh, excuse me. Let's see. So I have to open it one more time. So you can see that you have actually different. So forget about these two rows for now. I'll actually explain them more. Midas will automatically define these scale factors. So these scale factors are actually the ratio between the short-term and long-term properties. For example, this parameter factor IYY, if you forget about these two rows, these are actually the ratio of the moment of inertia about the major axis for the short term, computed based on n, divided by actually moment of inertia for the long term, computed based on 3n. So that's why they are smaller than 1. So this is a factor for I about the major axis, for I about the minor axis, for cross-sectional area, and other properties of the section. So this is the way that Midas will consider creep or long-term effect. This is the way that Midas. But if you leave it like this, and analyze your model and define construction state, Midas will use these properties, line properties, even when analyzing the bridge under live load. So the deflection or the forces, bending moment that you are getting, all are based on a line-term effect that are not true. So this was my. So in order to resolve this issue, this was what Midas actually support team suggested at the end, as I said, after a long conversation, and I tried to make sure that this is correct, and I believe that based on what I have done, it's correct actually. So
Hamid, this is true. I'm sorry. Yeah, this is true because the thing is that Midas live load, we have always to keep in mind live load is not part of any construction analysis. It's always going to be after a post-construction analysis. So that's why whenever you use when you define the stiffness of the beam using the long-term effect at some stage of your construction, let's say after you finish all construction, you have a stage that you are utilizing the stiffness of the beam in the long term, or you define this 3n factor, which is the long-term modular ratio. The live load, because the live load is not part of the construction stage, so it's always applied post-construction. So it's going to utilize the long-term stiffness. I agree with you. That's totally correct.
Exactly.
That's why the way that I see to do it is having those two models. I know that it's a very primitive way, I admit, But the thing is, if you want to really have this addressed, you can have a model with the short-term stiffness defined, and you use this to get the live load effect from it, and you can have the other one built with the long-term stiffness, and you can get your dead load effect from that one. So that of course will resolve the issue. But about having the two, I know that your goal is to get everything from one single model, and that should be always the case. That's definitely something that we all want to do. But this problem is evolving from the live load case is a post-construction stages. It's after the construction stages are all completed and applied, and that's why Midas by default is going to use the long-term stiffness under the live load effect, because that's how it's going to be handled. But I agree with your point about this, and that's why.
Yeah, thank you so much.
Yeah. Okay. Go ahead.
Thank you so much, and yeah, thank you for clarification. Yeah, that makes a lot of sense to me. So this is how actually they propose. So we have two stages: construction stage number 1 and 2. These are the normal construction stages that we usually define. For example, the first one is when we don't have composite action. We have the wet concrete. We have the steel beam, and the second one is when you have composite action. I'm not going to open them because they are just. But they said that I need to define an additional construction stage called, for example, dummy. And then if I open it, modify, so I have nothing under the element actually list. I have nothing under the actually load list. So group, I have no load. I have no actually element, but I have a boundary condition, as you can see here. So this boundary condition that I actually named it final is this. So I have in group, I have defined a new actually a boundary condition. I called it final, and then I am actually going back to this menu, to this option, section stiffness Scl factor. If you open it, you can see that in addition to the for each section, in addition to the two first rows that are actually the parameters that I mentioned, Scl factors, in order to take into account the long-term stiffness, the creep effect. So one of them is I, and the other one is J. The first row is I, the second row is J. I is just the beginning of the element, and J is the end of the element. So I have added two more rows here that, as you can see, I have modified all numbers to 1. You see, all of them are 1. So the boundary group here is final, as you can see. So for the first two rows, as you can see, the boundary group is creep 2, that corresponds to what Midas itself automatically defined, and now this is what I myself have defined. I have defined the final, and then I have changed everything to 1. So I have done it for all composite sections. So as you can see, for all composite sections, I have two different sets of numbers. These numbers are numbers that consider long-term effect, and these numbers are numbers that actually change the stiffness in such a way that you will use the actually short-term stiffness. Because as I said, these numbers are nothing but the And
exactly. I just wanted to say the first two rows represent the long-term effect, and the last two rows, the one rows, represent the short-term stiffness.
That's exactly.
Got you.
Yeah. These are what Midas automatically defines based on, as I said. So if you go to the section properties here, section properties, so you can see that if you show calculation results, so you can see that Midas had 3 different values, or even 4 for shrinkage as well. So you have before composite action, after composite action, and long term. These are based on N, the second column, and the third column are based on 3N. So then the factors that I showed you are nothing but, for example, this column divided by this column. So now, in order to have the correct values for post-construction stage, they recommended that I just need to, as I said, come here and then add these additional actually factors, and then they belong to boundary group final. Whereas the first two guys, the first two rows belong to creep number 1 for this section. This is what Midas defines when you actually activate this option, the option of this option. Yes, this one. If you check this on, then Midas automatically will define this section stiffness scale factors for each section that you are defining. So yeah, and then as I said, in construction stage, you just need to add this dummy stage and then modify. The only thing that you will activate is this final group.
The final
so
one.
This way, yeah, exactly, this final boundary condition. So I have actually examined this approach, and I have learned that if you do this, Midas will correctly use the short-term stiffness for live load analysis. Exactly, and for any post-construction, it could be earthquake, it could be live, it could be wind, and also it will use line-term properties for other dead loads, such as, for example, wearing surface, or for example, barrier loads, or whatever we call actually dead load after composite action. So this approach will be consistent with H2 LRFT. Yeah, this is what actually, after, as I said, long conversation with them and back and forth, we ended up with this.
So let me comment here and say that this is really actually a very good, excellent approach to trick that issue that we have inside Midas. I agree with this. Like, now you associated the long-term stiffness with a boundary condition or a boundary group that you named as final, where you are using the stiffness, the short-term effect, and the long-term effect are creep 1 or creep 2. This is just basically introduced here in the shape of a boundary condition, and you call it creep 1 or final. And then you have a construction stage that is associated with creep 1, where you look at the dead load effects, and you have the construction stage that is utilizing the final boundary condition and use it for the live load effect. And now this final one reflects the long-term, the short-term stiffness, and the creep 1 reflects the long-term stiffness. So I think this is a perfect way to do it. So you can introduce it in the form of a boundary condition. That was the big question that I was thinking about, like how to introduce those two different stiffnesses in the construction stage window. So in construction stages, you can activate or deactivate an element or a boundary condition or a load. So this stiffness cannot be introduced as an element or a load. So that's how they advised you to do it, through a boundary condition. So I agree with this method. I mean, it's a good way to do it, that you have one model and you can get the results correctly out of this model for the live load using the short-term stiffness and the dead load using the long-term stiffness. That's a good approach to do it.
Yeah, thank you so much. And I have one more question regarding the. So as you know, can I ask my second question? First, I check with you if you have time, because I think we are out of time, right?
Yes, we are like about 50 minutes behind
So
our
maybe
supposed
another
time.
time. Yeah, maybe
But
another.
but Amir, is it possible? Is it okay for you if Hamid asks one more question, or do you have any other? Yeah, okay,
I'm
Hamid.
okay. I'm okay, definitely.
Thank you so much.
Thank you for
so
your
much.
time.
I try to be quick, as quick as I can. So the question is that actually, based on H2, imagine we have a simply supported beam. So we always have the beam is again composite. So for a simply supported beam, we always have positive moment. So meaning that the concrete is always in compression. So we are not worried about the cracking of concrete due to tension. But if you have a two-span bridge like the one that I showed, we have near the mid support, we have negative moment, meaning that the top of the section is in tension, so the concrete will crack, and we have only the steel and also the reinforcement above the section, if any longitudinal reinforcement. So based on H2 LRFT, when we are actually determining the capacity of the section, or we are computing the stiffness, we obviously in the negative moment region, we actually disregard the effect of concrete, and we assume that we only have the steel section alone. That makes sense because the concrete has cracked.
Correct.
But
Yes.
the issue is when we are analyzing the model to get the actually the existing bending moment and shear force due to live load, dead load, etc. So I have actually looked at Ashto LRFT. Ashto explicitly mentions that in order to analyze such a case, you do not need to consider cracking. So you can assume that you have the actually composite section along the length of the beam. The entire length of the bridge, you have the full composite section without actually considering the crack. So you will actually use the composite section in both negative and positive moment. You analyze your model, and you will get the, for example, bending moment in negative moment region. And when you compute, you are computing the capacity or the stress, you will actually use only a steel section. So I just wanted to double check with you to see if my understanding is correct, and also have your opinion about it. I think there is an inconsistency here, so I'd like to hear your opinion.
Okay, so let's agree about some things first. So this composite stiffness, of course, under dead loads, when we are talking about the weight of the fresh concrete of the deck after pouring the deck, and the weights of the diaphragms and all those members, those are basically applied on the steel section only, on the girder section only. So we know that we are using the stiffness of the steel girder only to resist those loads, those dead loads. The composite action is activated. Yeah, definitely the composite action is activated for the live load effect, the barrier effect, those kinds of loads that come after the deck is hardened and we have the composite section. So if your question is about modifying the stiffness of the composite section in the region of the negative moment, because I agree with you, yes, in this region of the negative moment, the total moment applied on the girder will exceed the capacity, the cracking capacity of the deck on the top of the girder. And that's why we say the concrete is cracking in the deck, and we cannot really consider the section to be functioning with the full stiffness or full composite section stiffness. So this stiffness means that in this region of the negative moment, the stiffness of your section is going to be less than the full composite section in the positive moment region. So this, yes, this affects especially in the indeterminate structure, because we all know that the stiffness plays a key role, important role in the distribution, the moment distribution over the positive and the negative moment sections. This always happens in indeterminate structures. So what I honestly do in a case like this, that in the negative moment region, I have to define a section that counts only for the stiffness of the steel beam and maybe the reinforcement in the deck, and totally ignore the concrete effect, of course, because we consider the concrete cracked in this region. So this means that the stiffness of the section at this region is going to be less than the composite section in the positive moment region. So I have those elements, and usually I utilize a section with a stiffness that reflects the steel girder and the reinforcement in the slab only. And to do this, you can simply do it by, for example, if you take the same composite section for the positive moment and just apply a multiplier in the section stiffness window, just see what factor you need to multiply the stiffness of the full composite section just to reflect the cracking of the slab at this location. And just define those elements using this section. This is going to affect your result because it affects the moment distribution in the structure, because it's an indeterminate structure. So I would say this is something that's important to consider. If you consider the composite section along the entire length and ignore the issue of the cracking of the concrete in the deck in the negative moment region, this is going to change your moment results because of the indeterminacy of the structure, that you are using consistent stiffness along the entire structure. So you have to expect that the moment applied, the negative moment to the positive moment, the ratios between the two is going to be different for this case. When you consider the other case, when you crack the slab in the negative moment region. So yes, this has an impact on the analysis in the moment distribution. And to consider it, it's just simply defining a new section for this negative moment region that only reflects the stiffness of the steel girdle and the reinforcement in the deck.
Yeah, I agree with you 100%, and this is what actually Midas support team also recommended. But my question is that in practice, do you yourself actually neglect the contribution of concrete in the negative moment region or not? Because AASHTO actually allows us to consider that everything is composite. But as you said, if we assume that everything is composite, so we are actually fictitiously increasing the stiffness in negative moment region. It means that that region will absorb more moment in our Midas model, and it will reduce the moment in mid-span. But in reality, the moment in mid-span is longer, so is actually larger. So we are with this approach, we are conservative in negative moment region, but we are unconservative in positive moment region because we are reducing one of them and increasing the other one.
Yes, that is totally correct. In practice, in reality, what I do for my in my bridges or in what I model, I consider the cracking of the concrete, because ignoring this, like you said, is going to provide more stiffness in the negative moment region. That is not really true, and this means that this section will see higher moments than it will actually see after cracking of the deck. So this puts more moment on the negative region. That's not really true or realistic. And on the other hand, it reduces the moment on the positive moment section, which you expect that's going to see more moment because of cracking of the slab. That's why, yeah, in reality, I do it for myself. I agree that for those continuous composite sections, we should treat the moment, the section in the negative moment region differently from the positive moment region, with different stiffness and different properties to reflect or to take into consideration the cracking of the deck. Yes. So the answer of the question, yeah,
and
is
our
yes.
discussion, our discussion was actually obviously related to just live load and the wearing surface and barriers, because as you mentioned correctly, for the dead load before the composite action, we just have this alone, so we do not have the issue of cracking or cracking of concrete because there is no concrete.
Yes.
Yeah, I agree with you 100%. That's what I've done it, for example, and for some cases, very important. I was doing some load rating actually project. If I assume that, for example, the concrete is cracked in negative moment region, for example, the rating factor was above 1, but if I assume that that was non-cracked, so it was, for example, 0.7. So I had 30% difference between two cases. That was very actually,
and it becomes of more significance when your span gets longer, because for the longer ones, you have to expect that your positive moment will increase significantly after you reduce the stiffness at the negative moment section. That's the moment that's being redistributed between the negative moment and the positive moment. That's a very important issue.
Yeah, because we have, at the end of the day, the static moment is constant. It's just W L squared over 8. So it's positive and positive and negative, and it depends on how you introduce the stiffness for different actual regions, positive and negative moment region. Yeah, I appreciate that. Thank you so much. I think I got actually response to my.
So Hamid, I just want to say, I just want to say something. Honestly, I learned something new today about this boundary condition, that you are introducing the effect of the long-term stiffness, including creep and shrinkage, through a boundary condition in the construction stage analysis. I would say I usually did it the classical method while having two models, but now you guys saved me the time to build two models or just copy the model and getting the results from two separate models. I think this is a very smart, excellent way to do it, and introducing it through a boundary condition is really excellent. So
yeah, thank you so much, and I should appreciate really Midas support team, because they were very patient. I was asking so many questions, and I sent my model to them, and we actually discussed a lot. And so I can actually, I think I can share this model with all of you guys. If you just in case that you are interested in actually using this approach, because I found it very effective. Because when you are, for example, doing load rating or design, it's very tedious to use two different models, as you can imagine. So with this one, you can just use a single model. I can just share this model with you, and you can just try to understand what actually they propose and what I have done here to make it work as we want.
Yes.
Wow. Thank you, Hamid, and yeah, thank you so much for Amir, yeah, and yeah, since I would love to ask other questions, but since we are running out of time, I will conclude today's Q&A session here. But yeah, thank you very much for sharing your own strategies. I'm really happy to hear that both of you are learning something new and confirming each other today. Thank you very much for your time, and yeah, feel free to reach out to our technical support team or us if you need any further assistance. But yep, thank you very
So
much.
Hope, can I say something, if you don't mind? Just
Yeah,
to the rest of the people, just
okay,
because
sure.
I just feel bad that we did not have enough time to answer your questions as well. So just feel free if you want to contact me with any question that you have, or we can have any other session in the future organized so we can cover your questions as well. I know 30 minutes is usually a limited time, and the topic of composite bridges and construction stage analysis is a very interesting and popular one. And it's very common, of course, in this country, building those bridges. So just wanted to express that I'll be available to answer your questions through emails, or even if we have sessions in the future. Thank you.
Thank you so much for your
Thank you so
offering.
much, Amir.
Thanks, Hamid.
Yep.
Thank you so much, Amir, for your time. Thank you.
Yes,
Thanks.
thank you all, and have a great lunch and the rest of the day.
All right, thanks.
Goodbye.
Okay, bye-bye.
Bye.
Bye.